This is Algebra 1, Unit 10, Lesson 4 on variation within a data set. Okay, now we've been talking about measures of central tendency. That's mean and median. They give us numbers that describe the typical data value in a given set. So when you're talking about the measure of central tendency, you're trying to make one number that is typical to that set. Okay, but they do not let us know how much variation there is in the data set. Two data sets can have the same mean, but look radically different depending on how varied the numbers are in the set. So what we're going to look at is two different measures of variations. The first one is called the interquartile range. Two data sets below each have equal means, but differ in the variation within the data set. Use your calculator to determine the interquartile range for each data set. The interquartile range, IQR, is defined as the difference between the third quartile value and the first quartile value. All right, so the IQR is equal to Q3 minus Q1. What it means is 50% of the data falls in that range. Okay, so when we talk about the interquartile range, we need to know quartile 3 and quartile 1. So I've already entered mine in the calculator. All right, so if I go to Stat and Edit, all right, I put data set 1 in L1 and I put data set 2 in L2. All right, so what I need to do is I need to figure out Q1 and Q3 for each of those. So if I do Stat, Calc, various statistics, and I want to do L1. All right, so this is L1. Go down to Calculate. All right, now remember Q1 and Q3 are down here. Here's Q1, here's Q3. So Q1 is 4.5 and Q3 is 9.5. Q1 is 4.5 and Q3 is 9.5. So IQR for this one will be 9.5 minus 4.5, which is 5. Okay, so that means 50% of the data is within 5 points. Okay, all right, so let's look at data set 2. We need to know what Q1 and Q3 are for that one. All right, so I'm going to use my calculator, Stat, Calc, var stats number 1, but this time I want to do L2, so I want to press second and then L2, which is number 2. Notice it's in blue right here, L2. That changes this to L2. Go down to Calculate. All right, so Q1 in this case is 6, and Q3 is 8. All right, so this is 6, and this is 8. So your IQR will be 8 minus 6, which is 2. So that means 50% of the data is within 2 points of each other. So which one is more spread out? This data is more spread out because the IQR shows that the data is within 5 points of each other, but this one's only within 2 points of each other. So that tells us the spread of the data. So that is an example of IQR. Now you can also do this on Desmos. All you have to do, here's Desmos. I entered data 1 in A, I entered it in B. For the second one, this is data set 1, this is data set 2. So to do that on Desmos, you just go to Functions, go over where it says Stats. So if I wanted to do A1 here, quartile, oops, I'm on the wrong one. Sorry. Gotta go to the next thing. Oop. All right, so if I go to Function, quartile, all right, so if I want to do A, I would press A, comma, 1. Where's my comma? 1. There's quartile 1. All right, and if I wanted to do B, I forgot to put my other numbers here. It's 2 9s. There we go. All right, and if I wanted to do B, you go Functions, quartile. Say I wanted to do B, quartile 3 of B. So I would put B, comma, 3. So there's my 8 that I had. So all you have to do is enter each of your terms in brackets with a letter, and then do the quartiles for each one of those. the interquartile range gives a good measure of how spread out the data is. So you can see 50% of the data falls within 5 points, 50% of the data falls within 2 points. But the best measure of variation with the data set is called the standard deviation. The actual calculation of standard deviation is complex. We will not go in there. We'll rely on our calculators for its calculations. All right, so using the same data sets above, use your calculator to produce the standard deviation, which is shown as this a theta symbol, or I forgot what symbol this is, but anyway, on the calculator of the two data sets. So this is also called the population standard deviation. There's two different kinds. This one's called the population standard deviation when you use this symbol. All right, so for data set 1, what you do is if you look at stat, calc, var stats, and I want to go to L1 again. All right, and then go down to calculate. The population standard deviation is this one right here. So rounded to the nearest tenth, this is going to be approximately 2.7. Whoops, wrong one. This is going to be approximately 2.7. All right, now if you want to do this on Desmos, you would have to use function over here. Now, population is the omega one, so that's going to be this one's STDVP with the P on it, and there's DEV, that's the sample one. This is the population one, this is the one you want. So STDVP, and then if I wanted to do of A, you can see it's the same number as what I have right there. All right, so when you do it on Desmos, you have to use the one with the P on it if you're doing a population standard deviation. Population just means the whole group that you have. All right, so data set 2, you would have to do the standard deviation, so it would be stat, calc, var stats, and this time it'd be L2, so it's second and then 2. Go down to calculate, and you can see it's going to be 1.4. So this is going to be 1.4. Okay, so that is how you find standard deviation. The standard, what is it exactly though? The standard deviation of data set tells us on average how far a data point is away from the mean of the data set. Okay, so we have to know where the mean is and where each point falls in relation to the mean. The larger the standard deviation, the greater the variation than the data set. So the bigger the number of the standard deviation is, the farther the points are from the mean. So that means that your data must be more spread out. Okay, so let's take a look at the next problem using standard deviation. Oops, sorry. Move it down here a little bit. A farm is studying the weight of baby chickens or chicks after 1 week of growth. They find the weight in ounces of 20 chicks. These are the weights shown below. Find the mean, the interquartile range, and the standard deviation for this data set. Round any non-integer values to the nearest tenth. Include appropriate units in your answers and give an interpretation of the standard deviation. Okay, so I've already entered this in my calculator. You can do it on Desmos if you want to. All right, so I want to find the mean first of all. So it's stat, calc, var stats. And I want list 1. Go down to calculate, press enter. All right, mean is 3.7. That's this first X bar right here. So the average weight of the chickens, baby chicks, is going to be 3.7 ounces. Okay, now the interquartile range, remember, is Q3 minus Q1. If I go back to my calculator, all right, Q3 is 5, Q1 is 2.5. So Q3 is 5, Q1 is 2.5, 5 minus 2.5 is 2.5 ounces. Okay, so that means 50% of the data is within 2.5 ounces. Okay, so that tells us how spread out it is. And then the standard deviation of the population, which is this symbol right here. If I go back to here, that is going to be approximately rounded to the nearest tenth, 1.7 ounces. Okay, so the interpretation of the standard deviation says that on average, a typical chick's weight is 1.7 ounces away from the mean weight of 3.7 ounces. So that means that if I were to pick a weight of the chick on average, the average weight is 3.7, but each point is going to be about 1.7 away from the mean. It's not going to be really far away from the mean, but all those values are going to be within about 1.7 ounces of the mean. That's what standard deviation is. So standard deviation is the distance away each point is away from the mean. So if I picked any point here, it's going to be on average about 1.7 ounces away from the mean. So that tells us how spread out the data is. All right, now let's look at the next question that we have about standard deviation. A marketing company is trying to determine how much diversity there is in the age of people who drink different soft drinks. They take a sample of people and ask them which soda they prefer. Now notice when I said sample, you can't ask every single person in the world every time. So what they're doing is they're taking what's called a representative sample. It's just a bunch of people in a group from the population. For the two sodas, the age of those people who preferred them is given below. So we have soda A and soda B that we have here. All right, so let's figure out what the mean and the standard deviation is for each one of these. All right, so we need to know the mean and we need to know the standard deviation. All right, I already put these in my calculator. So stat, edit, I'm going to do L1, which is the first group. Stat, calc, var stats, I want L1. So my mean in this case is going to be 26.7 and my standard deviation is 8.8. All right, so my mean is 26.7, my standard deviation is 8.8. All right, for my second group, stat, calc, I'm doing var stats, but this time I'm doing an L2, second 2, and I want to calculate, enter. My mean is 23.4, and my standard deviation is this one right here, 3.9. 23.4, and this is 3.9. Okay, so explain why the standard deviation better measures diversity in age than the mean. Okay, so for soda A, they're saying the typical mean only gives you the typical age. The typical age of the group. All right, so the typical age of this first group is 26.7. Okay, but does that say how spread out it is? No. Notice that we have a high age of 44 and we've got a low age of 16. So, but it doesn't tell how spread out the data is. The data is. So this one says that even though the average age is 26.7, on average, each point is 8.8 away from the mean. For this one, the average age is 23.4, but the standard deviation is 3.9. Each point is 3.9 away from the mean. So that means that this one is more spread out. Each point is about 8.8 away from 26.7, and for this one, each age is about 3.9 away from 23.4. So this one is the higher spread. Which soda appears to have a greater diversity in the age you prefer it? It would be soda A because the standard deviation is higher. Is higher. The data is more spread. Okay, so we want to use the calculator to determine the sample standard deviation given as S. So that is the other standard deviation that you use either on Desmos or the other. So it would be this bar one right here on right above the 1. So the other one is 4.1 and the other one is 9.1.